So, in this the lecture session, I will be referring to the process capability ratios and their measurement. Now, as I have already mentioned that there are different types of process capability ratios, and they are known as Cp, Cpu or Cpl, Cpk, Cpm. So, if you go through the literature, if you go through the textbooks on quality related to process capability analysis, the researchers, the practitioners, they have recommended all these ratios for measuring process capability, okay, under different conditions. So, we will explaining those conditions thoroughly, and we will also explore the relationship between Cpk and Cp. Essentially, with Cp, we try to assess the potential of a process, and if the potential is assured, then you will go for measuring the process capability. Is it okay? So, what could be the relationship between Cpk and Cp, we will explore, and what is the basis, scientific basis of selecting right kind of process capability ratio. This is an important issue. We will also discuss this aspect. Now, let us discuss these ratios one by one. Okay. And the first the term we use, that is called process capability ratio, that is known as PCR, and PCR sometimes it is referred to as a Cp index. In fact, sometimes this process capability ratios are also referred to as the process capability indices. Is it okay? And as they are in the ratio form, that is why I prefer this terminology called ratio. Now, how do you define PCR or the Cp index, right? Now, here what you find that on the numerator you have USL minus LSL. Is it okay? So, what is USL minus LSL for a the double specification limit case? That means with respect to a particular quality characteristics. That means the first thing you must do, that you have to select a process for the given the process or the select process. Now, you must identify that which particular component you are going to produce. Obviously, you must know that related to the process what kind of operation you will be getting vis-a-vis that component. Once the component is known, that means you look at the component, the drawing, and definitely you will find that a particular quality characteristic you will be processing, okay, with the help of this process. So, with respect to that particular quality characteristics, you must know what is USL and what is LSL. Now, actually this the two values or the specifications limits are prescribed by the designer. So, you must have these details. When you look at the engineering drawing, you will find the limits are given, specification limits are given, and you will also come to know what is the nominal dimension, okay, and it is a double specification limit case, okay. So, if it is a single specification limit case, either upper or the lower, is it okay? That means upper specification limit means, that means the quality characteristic is such that the value of the quality characteristics must not cross some upper limit. Like so, the temperature of the oven must not cross say 1200 degrees Celsius. Is it okay? So, any value which is technically feasible less than 1200 degrees Celsius is acceptable to you. Is it okay? That is the upper specification limit case. Whereas, the lower specification limit case, like say the tensile strength of a particular say the material must be at least 3000 kg. right. So, if kg per say whatever may be the unit, like the square is like centimeter, square centimeter or the square millimeter, whatever it is. So, so that is the minimum value is specified. Any value greater than of this minimum one is acceptable to you. So, that is a lower specification limit case. Now, so here USL minus LSL is basically the specification spread we have already defined. And then what is this 6 into sigma? That means the sigma is the process standard deviation, and what we have assumed actually 6 into sigma means the distance between say U and TUL, upper natural tolerance limit minus lower natural tolerance limit. That means what actually you have observed, okay, and this is actually referred to as the actual spread. Okay. So, in the denominator when you write 6 into sigma, we are assuming that the distribution of x is normal and U and TUL is placed at plus 3 sigma from the mean, and similarly L and TL is placed at minus 3 sigma from the mean. Okay. So, this is nothing but the actual spread. That means it is allowed spread versus the actual spread. So, obviously, if the process needs to be capable when the process is centered, what do you assume that Cp must be greater than equals to 1. Is it okay? Like you refer to case 1, this is basically we are referring to case 1, and what we are assuming that the process is centered. Is clear? That means here while you propose this particular ratio, nowhere we mention the location of mu, we are only referring to the sigma, right. So, basically we say it is a capable process, but more specifically means the actual wording should be that if you find that the Cp is greater than 1, that means the process has got the potential to be capable. So, it is had adequate potential to be capable. Is it okay? So, this is the first condition you have to, or the necessary conditions you have to satisfy. Is it clear? Now, the next one is upper and lower capability index. Now, upper capability index we propose when the quality characteristics is of upper specification limit case. Is it okay? Or the single specification limit upper, and in case you deal with a single specification limit with lower, is it okay, the lower limit mentioned, then we will be referring to the lower capability index. How do you define CPU? That means just USL minus mu. Is it okay? So, you have just from the mu to USL, that is basically that is the actual or the allowed spread you allow, okay, and on that side what is basically the distance from the mu to the U and TUL, that is 3 into sigma. So, what is the desirable value? That means the CPU must be greater than or equals to 1. So, it should be at least 1. But if you deal with single specification limit case with the lower limit to be checked, then you refer to the CPL. So, here mu minus LSL, that means mu is always greater than LSL. Okay. So, that is the allowed spread, okay, and divided by 3 into sigma. Is it okay? You just refer to the one side, okay, of the mu. Is it okay? And for the process to be capable, you say the CPL must be greater than or equals to 1, right? The same logic you have. Now, here the actual capability index, that is CPK. This is you just note it down that the CPK is actually the process capability index. And what is CPK? Actually, one way you say that this is the minimum of CPU CPL. Suppose you say that the CPU I compute as 1.2 and the CPL is say 0.85. So, obviously, the CPK will be 0.85. So, minimum of CPU and CPL. You will have other expressions for CPK, we will refer to this, and you will have the clear cut understanding of the factors affecting the CPK. Okay. So, from the CP we move to CPK. Now, this is just elaboration on say CPU. That means, here it is mu, you are considering just this side of the distribution. You have somewhere USL. So, actually you can this value any value between mu and USL is acceptable. So, USL minus mu is actually the allowed spread, and but what you have that UNTUL and mu, that means the process should be restricted within this limit. Is it okay? So, that is why it is when we compute upper capability index, we refer to this particular diagram figure. Similarly, when you refer to the lower capability index, you have the LSL over here and the mu. Now, this any value between this and this is acceptable to you. Is it okay? But if the process is like this, that means LNTL will be somewhere here at 3 sigma away from mu. Is it okay? So, you have to identify this one, and then this point, obviously this is the actual one and this is the allowed one. So, allowed divided by the actual will be the capability index. Is it okay? So, lower capability index, this way defined. Now, let us elaborate on CPK index. Is it okay? You have to define what is K. Now, a measure of the deviation of the process mean from the target value. Target value is M. So, what is M? Unless otherwise specified, it is basically the midpoint between USL and LSL. So, we are considering a two-sided double specification limit case for illustration, and so the M or the nominal value or the desired value is USL plus LSL divided by 2. Fine. So, now there is no guarantee that the process mean will be coinciding with say the target value or the nominal value of a given quality characteristics. So, there could be some difference, and this difference may be significant. So, what we try to do, you try to measure this difference. Is it okay? So, this is M minus mu absolute, that means the difference either on the positive side, either M could be, say the mu could be greater than M or mu could be less than M. M is constant, whereas mu is a variable, mu is a function of time. So, with reference to M, mu may be greater than M or may be less than M. So, what you try to do, that means you get the absolute value, that means the difference. Okay. Now, this difference must be must be made dimensionless. So, what you try to do, that means you define K as a proportion of this one. Okay. So, that means this is the distance. What is the distance? USL minus LSL divided by 2. Is it okay? So, that is the distance. So, as a proportion of half of that distance between USL and LSL, you define K. So, as a proportion, that means this K becomes dimensionless. Is it okay? So, as a proportion of the distance between USL and LSL, half of that, right. So, this way if you define K and we have defined what is M, then you get the relationship of Cpk is equals to Cp into 1 minus small k, 1 minus small k. Is it okay? So, now there could be 3 conditions. It may so happen that suppose the value of k becomes 1, right. Whatever may be the value of Cp, suppose it is greater than 1, suppose it is 1.5, 1.67, that is ultimately the process capability as defined by Cpk will become 0. So, there are many cases. It may be, there could be cases that the process has got the potential, but the way you handle it, the way you try to the control its parameters, but it is wrong. So, obviously, you are unable to control the process parameter settings. So, you may find these situations. That means, even if the process is absolutely all right from the design point of view, from its potential point of view, but you cannot control the process, and ultimately the majority of the outputs or the units you produce, they may be out of tolerance. So, that is why Cpk could be very less. Is it okay? So, there are cases in fact. Now, first case is LSL less than equals to mu less than equals to USL. What you must ensure that, suppose you say that the mu is a variable. Now, mu can assume any value in this range. Is it okay? Like say mu at extreme case, mu may be equals to USL, or mu may be exactly equal to LSL. Is it okay? That means mu falls on LSL or the mu falls on USL at that point in time. So, what you find that if it falls on USL or LSL, you will find that the value of k could be 1 or the value of k could be 0. So, if it is 0, that means the process is centered. That means m is equals to mu or mu is equals to m. Is it okay? So, k becomes 0. That means, if Cp is 1.5 or say 1.67, Cpk is also 1.67. So, that condition you must be able to reach. And what is these conditions we are referring to? This condition is referred to the centering of the process. That means, the first exercise you try to do, you try to reduce the distance between m and mu. Is it okay? So, you can't do anything on m, that is the pre-specified, the location is known, but the mu's location is a variable. So, you try to create a condition, the process settings in such a way that majority of the times mu is coinciding, or it is almost same as m. Is it okay? That means, there is no the significant difference between the value of mu and the value of m. Is it clear? So, this is okay. If the process mean is at m, then k equals to 0, and if k equals to 0, Cpk is equals to Cp. Whereas, if the process mean is at USL or LSL, I have mentioned LSL less than equals to mu less than equals to USL. So, this condition may arise. That means, if the process mean is at USL or LSL, k is equals to 1. You just compute this one, you will find that the value of k is 1, and if k is 1, obviously it is 1 minus 1 0. So, Cp into 0 equal to 0. So, Cpk equals to 0. Now, the question comes that suppose there is a drifting of the process and the value of the mu, is it okay, and you suppose you have lost control and you find that mu is greater than USL or the mu is less than LSL. So, if it is greater than USL, that means it is a upward drift, uncontrollable. Is it okay? Or suppose mu is less than LSL, right? That means there is a downward drift. So, what will happen to the Cpk value? Obviously, in such cases you will find that the value of Cpk will be negative. Is it okay? So, there are the 3 zones you have for mu. First is mu may be anywhere between USL and LSL. The next zone is mu may be in a zone is defined as that is greater than USL, or it could be in the third zone, that means mu may lie anywhere, okay, it may assume any point less than LSL. So, in the first case you will have some value that means in the ideal condition when m equals to mu at the center, mu, that means the centering of the process, you get the most desirable situation. And but in other cases you will find that the value of CPK will be less than 1, and in certain cases, the extreme cases, the CPK value could be negative also. So, this is the most undesirable situation. Now, the researchers, practitioners, they have recommended values of PCR, that is Cp and CPK. So, if the process is an existing one, that means the process has been running for the last say 5 years, 10 years and all, is it okay? Successfully it is being run. So, existing process, if you deal with the two-sided specifications related to quality characteristics, so you say that the recommended value of PCR could be 1.33, it's clear. And if you deal with the one-sided specifications, then it could be 1.25. So, these are based on the experience, the researchers, the practitioners, investigators, they have recommended this one, is it okay? If it is a new process, obviously its performance is expected to be higher. So, you say for two-sided specifications, the value you set as 1.50, that is the recommended minimum value for PCR, and one-sided specification slightly less than 1.50, that is 1.45. If it is related to a particular quality characteristics like the safety, strength, like the tensile strength, okay, or some critical parameter, existing one, is it okay? That means the existing process, right? You are dealing with the existing process, but now you concentrate on a particular say the quality characteristics or say parameters. So, then you say if you deal with the two-sided specifications, it will be 1.50 and one-sided specifications 1.45. And if you deal with all these parameters or the parameters like safety or the strength, but you are dealing with a new process, you just installed, you set a value of 1.67 for PCR, this is the minimum value when you deal with two-sided specification. Similarly, for one-sided specification, it is 1.60. Now, we have already mentioned that the CPK. So, you just you refer to the what is CPK, that is the minimum of CPU, CPL. Now, the recommended values and a process that is not capable. If you look at this diagram, why I am saying that this process is not capable. Here you find that LSL is here, USL is here, and any value you get the above USL or less than LSL, is it okay? So, that value is considered to be non-conforming, right, and we are dealing with the distribution of X. So, obviously, there is hardly any value less than LSL, is it okay? There could be some certain cases, rare, there could be some one value isolated case, but usually there is hardly any value which is less than LSL. But there is this is the area, that means there could be many values, is it okay? When your production rate is very high, that means there could be many values you may expect, right, which these values are greater than USL. So, if they are greater than USL, they are referred to as non-conforming, okay. So, suppose this is a 10% or a 15%, is it okay? Proportion non-conforming. What do you conclude about the process performance? You say the process performance is not at all acceptable, is it okay? If you control it within 3%, even in many cases 3% non-conforming, its cost implication could be very, very serious, very high. So, it may not be acceptable to you, is it okay? So, we say that the process that is not capable and CPK is less than or equals to 1. Why? Because here you find that there is a substantial distance between m and mu. That means the process is not centered. If you can reduce the value of mu, is it okay? Reduce the value of mu, that you have not done yet. Then obviously, if it coincides with m, obviously that is the best possible situation, that is referred to as the centering of the process. Okay. So, but till now you will find, by looking at this diagram, you will find that there is a significant the difference between m and mu. So, whenever the process is not centered, there is a high probability that the process may be considered as incapable. Okay. The CPK, the probability that the CPK less than 1, this probability will be very, very high. Okay. Now, relationship between NTL and the specification limit for a process with a capability ratio of 1.33. So, how do you do that? That means here is mu and this is LNTL, and what you find that the distance between say LNTL and mu is 3 sigma, whereas distance between LSL and mu is 4 sigma. Is it okay? So, this is with respect to say the lower capability index lower, you find that this is basically 4 by 3, that means 1.33. Is it okay? So, that means always you remember one particular ratio, that means allowed spread divided by the actual spread. Is it okay? So, now the last capability index I am going to discuss, that is proposed by Taguchi, and as you know that the Taguchi says that you need to produce as per the target. Is it okay? Each and every value, that means each and every x you ensure that this x is this value is the you get, that is the target value. Okay. So, that is your goal. So, the proposed index is the notation is C subscript PM, okay, is defined as USL minus LSL for a two-sided specification limit divided by 6 into tau. It is not sigma. Is clear? Now, what is this tau? That means tau is the standard deviation. We calculate standard deviation, but with respect to the target value. Is it okay? And how do you get it? That means it is the general expressions you are already aware of, that that means expected value of x minus t square. What is t? T is the target value for the given quality characteristics. Is it okay? Not necessarily the nominal dimension. In majority of the cases it will be nominal dimension, but when you believe, when you apply the concept of Taguchi, you say that I will not say it is nominal value, I will say it is the target value. So, this the variance you need to calculate with respect to the target, not with respect to the mean. Is it okay? So, that is why we use a separate notation, that is the tau square, and then when you go for manipulation of these equations, you have these expressions. That means you say that it is expected value of x minus mu square plus mu minus t square. Is it okay? Obviously, we assume that there is the product term is absent. That means the dependency conditions we will not assume, but we say that there is no dependency conditions. Okay. So, under these conditions, this is basically the sigma square, that is the variance, and this is mu minus t square. Is it all right? So, this is the simplified expression for tau square, and when you substitute this tau in the CPM expression, substitute this expression for tau in the CPM expression. So, you get USL minus LSL 6 times the square root of this. Is it okay? So, this is basically tau square, and this is 1 plus delta square, where delta is mu minus t by sigma. That means so the mu is the process mean and this is the target. So, what is the difference between this? And this difference is expressed in the standard deviation units, and this is referred to as the delta. So, this represents, delta represents, small delta represents the deviation of the process mean from the target value in units of standard deviation. So, ultimately the CPM, that means USL minus LSL divided by 6 into sigma into 1 plus mu minus t divided by sigma square. That means the delta is mu minus t by sigma, that means root over 1 plus delta square, and you have USL minus LSL divided by 6 into sigma, that is the CPK, but original PCR. So, the CPM has got a relationship with the CP into 1 upon root over 1 plus delta square. Is it okay? So, this is so whenever you apply the Taguchi method and the process in the process you apply the Taguchi method, you believe in the concept of the target value for the given quality characteristics, and you are asked to carry out the process capability analysis. So, which particular index you should apply, that is the Taguchi capability index, and the basis is this one. Is it okay? So, I conclude this one. So, all sorts of the capability indices we have discussed, and the later on in the next lecture we will be discussing the other aspects of process capability analysis.